AJ started out as one of my ecology students last fall, is that when it was? Where we did individual projects in that class, and AJ's group studied fighting behavior in crayfish, and he had a great interest in that topic, and so he decided to join my lab to perform some research. So this is the result of his independent project in my research lab.
Good morning, everyone. So I'll be presenting my research on the effects of acoustic stimuli on crayfish fighting behavior. So we see fighting all across the animal kingdom, and it's largely centered around dominance. So if you can gain dominance over your opponent or your fellow conspecific, then you can gain access to limited resources and mating relationships. And so these are obviously important because if you can gain these resources, if you can gain these extra mating opportunities or relationships, then it just makes your life easier. You can pass on your genes more efficiently, and that increases your fitness overall. So a large part of fighting behavior is sensory landscapes, and that's basically how the organism detects their world around them. And so crayfish, in this example, they use their sensory landscape to detect predators, fellow conspecifics, and food items. And so all the sensory landscape is just the culmination of all of their senses. So these senses include visual, mechanical, chemical, and then all of that stimuli together form their overall sensory landscape. So all the sensory landscape is their detection of the world around them. So we know that information generally drives behavior in the wild. So in bullfrogs with their mating calls, and then also with salmon with navigation, they use these to perform tasks that are vital to their survival. And so if you remove that information, then generally you see a removal of the behavior as well. So it's very important to the individual that they have this information that they get from their sensory landscape. So noise is anything that impairs or prohibits information flow. So in this Where's Waldo picture here, that's an example of visual noise. So a term we use a lot when discussing this is signal-to-noise ratio, and that is exactly what it sounds like, just the ratio of how strong your signal is versus how strong your noise is. So in this example, this is a low signal-to-noise ratio. Your signal is very small, and your noise is obviously very large. And so it makes it hard to see where Waldo is. And so this is a great example of what noise does, how it affects the organism. And we know that noise doesn't only affect visual, but it also affects all sorts of modalities, chemical, mechanical, and so on. So crayfish rely on this information during these interactions, and in this Callahan study, they showed that not only that crayfish use information, but they also pinpointed specific sensory appendages, and then from there would lesion those appendages to really break down whether they're using their continuous here, their chelae, what's going on. And so from that study, we know that crayfish use these sensory appendages, and we know that they use information because if you remove those appendages and they no longer have access to that information, then the fighting behavior and generally the outcome of the fight is altered. So we know that noise obviously affects crayfish, and not only just with like mechanical, but also with chemical noise. In the Bergman and Moore 2005 study, they messed around with chemicals, and they increased different chemicals and showed how crayfish, it altered their behavior. A lot of times crayfish will emit urine at each other during fights, and so this is kind of like a back off kind of thing. And so if you can alter their ability to understand and interpret that chemical, then not a lot of times you can alter the fight and the fight dynamics. And the same thing with visual here. In this Brusky and Dunham paper, they altered light levels, and they showed that differing levels of light will also change the outcome of a fight. So the type of noise that I'm interested in is sound pollution, and more specifically sound pollution in the form of loud vibrations. And so these loud vibrations are generally centered around urban areas. So we know crayfish can receive and process auditory stimuli, and in this 2012 study, they took a community of crayfish and they put them in a large tank and allowed them to interact freely with each other, and then they introduced this stimuli, and they saw that in a community setting, overall agonistic interactions, or just fighting behavior, decreased whenever the auditory stimuli was played, and then afterwards, it immediately, after a short period of time at least, picked back up again. So we know that crayfish can at least receive and process the stimuli because they show behaviors when it's being played. So my hypothesis is that if we introduce this noise in the form of this vibrational sound pollution as a stressor, that it should disrupt the sensory landscape, and then from there we should see decreased aggression. And this decreased aggression should show itself in the form of shorter interaction times and lower overall intensity. So the particular crayfish we're using for this study is Cambarus kuzai, and we collected them all around the Jacksonville area. And we only use males form 2. And that's important because in this Martin and Moore study, they showed that males and females of differing sexual forms fight differently. And a lot of times there are different outcomes of fights depending on which form they are. So form 2 is the non-reproductive form, and so we used that just because we wanted to make sure we were completely isolated, and the only thing we were changing was in fact the sound vibrational stimuli. So we ran 9 control trials and 9 treatment trials, and all of these were isolated for a week before fighting. So all of our fighting was done in a plexiglass box with dividers, and then we obviously filled that box with water. So these dividers here are completely blacked out, and the only reason we did that was because when we put the crayfish in to be isolated before the fight, we didn't want them to have any kind of interactions. We didn't want them to see each other or get any kind of chemical or anything like that. We wanted them to be completely isolated, and so that's why we had the blacked out dividers. So when the week-long isolation, we kept crayfish in these aquariums, and we treated them with a vibrational stimuli. So we achieved this by placing aerators on the front and the back of the tank and then securing them with 2x4s. And so this vibration was left on the entire week, and it was the same. We just plugged them in and left them the entire week. So when it came time for fighting, obviously we would have the dividers in, and then we would give them just 15 minutes to acclimate to their environment, because we were obviously moving them from the isolation aquariums into the fight arena. So we allowed them 15 minutes just to get used to their surroundings, and then from there we would remove the dividers and give them a 15-minute period to fight and interact however they so chose. So the main data that we're pulling from these interactions is overall aggression in the form of max intensity and then also bout duration. And more specifically from that, we're only pulling from the first bout. So the first bout is just when the start of the interaction occurs. And then the first bout ends when a retreat behavior is shown or when the crayfish are at least one body length apart for 10 seconds. So we're looking at this overall aggression and this bout intensity, but we're only looking at it in the first bout. And the reason we use the first bout is because generally you see your highest levels of aggression during the first bout, and then also the first bout is a good indication of who's going to win the fight overall. So this is kind of a snapshot of just these later behaviors. This is a good indication. So we use the first bout just to kind of simulate how the rest of the fight is going to go. So this max intensity that I was talking about earlier, the way we quantify these behaviors is using an ethogram. So this is Bergman and Moore's 2005 ethogram. And as you see, the intensity levels go from this -2 all the way up to 5. So the 0 to -2s are what we would call retreat behaviors. And while they have these behaviors linked to them, for our particular study, it's not necessarily that important, just because if we saw a retreat behavior, the trial was immediately finished. That's where we would conclude it. But this 0 through 5 here was very key, because we could assign specific specific behaviors for a number, and then that's how we used to quantify it. So if you can see here, this 0 is just a visually ignoring opponent, and then you can go all the way up to 5 here with unrestrained fighting and pulling at opponent's claws. So we use this ethogram to quantify the behaviors that we're observing. So our results, as you can see here, we have controls and noise. We ran a chi-square test, and although we didn't see significant differences, we did see trends here. In the dark blue, you have escalated, and then the light blue, you have non-escalated behaviors. So what we mean by escalated and non-escalated is that this 0 through 3 on an ethogram, we just broke down, and we consider that a non-escalated behavior. And then a 4 and 5, we use that and consider that as an escalated behavior. So as you can see here in the controls, to the noise, we showed a decrease in escalated and an increase in non-escalated. And then very similarly, in the first bout duration, we also showed a decrease in the overall duration of the fight. For our first bout duration, we ran a Mann-Whitney-Wilcoxon test. And the reason we used this test was because our data was not normally distributed. So this test corrected for that. And although we didn't see significant results, as I said before, we do see this trend where the noise trials are not significantly, but they are shorter. So we see these trends in both maximum intensity and aggression, and also in first bout duration of these trends that what we're looking at, if we run more trials, might produce the result we're looking for. So our future studies obviously is to add more replicants to the data set. That is our goal for number one. And then some expanded research we want to do was adding another treatment of controls versus the acoustic stimuli crayfish. And the reason we want to do that was because that would really flesh out how the, or if and how the noise affects them. So if we see an advantage given to the controls, then we know that this noise is significantly hurting the experimental crayfish. Another thing we want to do was fight males versus females to see if this possible noise affects males and females differently. And then lastly, we would want to analyze our fight behavior with an expanded ethogram. So basically what we would want to do with the expanded ethogram is add more numbers to that. So ours goes to 0 to 5. The one we would be using in this expanded ethogram goes from 0 to 11. And so all this allows us to do is add more behaviors and get more specific, and we can truly see fight dynamics from a very specific point of view. And so that would help us really flesh out what's going on and how this noise affects crayfish on a more specific level. So with that, I would like to acknowledge the Jacksonville State Department of Biology, the Behavioral and Sensory Ecology Lab, and lastly, Dr. Sarah Wofford for all her help. I could not have done it without her. And with that, does anyone have any questions?
Okay, that was very interesting. Thank you. Why are we concerned with the fighting habits?
Right, so basically crayfish establish dominance hierarchies, and that's a very important part of their social, how they interact with each other. And so a lot of times these fighting behaviors influence who gets resources, who gets mates. So if we see that fighting behavior is altered from this noise, then that could alter social relationships, that could alter a number of things. And then if you can even break it down to different species, if this noise affects one species more than another one, so it's very important for their social dynamics. And so if we can tell a difference, tell it's affecting it, then that we can show that it's affecting their social behavior. Any more questions?
I have one.
Okay.
So you mentioned that your results are not significant.
Right.
I'm imagining because your population was low.
Right.
So you would consider this more of a pilot study?
Absolutely. This was just kind of a first pass. As soon as the collecting season comes back around, we're going to collect more, and then over the summer, we're going to run more replicants. And
So
then
that was kind of my question. When you said you collected the samples from this area,
Mhm.
were you limited in terms of the population of crayfish in this area, in terms of how many you were able to recruit?
That's a very good question. So we collected a lot. One thing was just time-wise, just running that many trials and then getting data collection and that kind of thing. Towards the end, this past year, we did have a decrease in the amount of crayfish we collected overall. And it was more of a timing thing, I think, than necessarily just not having crayfish, but maybe a little bit of both.
For your ethogram, are you getting a single score per bout, or are you getting multiple events that you add up to a total score?
Right, so the way we scored the ethogram is we would watch the fight overall, the two crayfish, and then if we observed the behavior, we would check it off of we've reached a 1, we've reached a 2, and then all the way up to 5. And that's for both crayfish interacting. So we didn't assign scores to a single crayfish, it was to the collective. If we saw this behavior reach this intensity level, we would check that off, and then so on all the way up.
Okay, so So basically one final score.
Right, exactly.
And if they ran away, that was the end of the game. If they immediately went to a 5, that was the end of the game as well.
Well, if they went to a 5, we would obviously let the trial keep running all the way to the 15 minutes. But if they reached the 5 in the first, say, 30 seconds, then that was as high on the ethogram as they could go. So,
Yeah.
exactly. Any other questions?
All right, I think we're